Hello, Hamna, can you hear me? Yes, Hamna, can you hear me? Yes, hello, am I audible to both of you?
Yes, ma'am.
Yes, ma'am.
Okay, welcome to the class. So today, I think the linear equation was over in the last class, and today I'm going to start a new chapter, which is called arithmetic progression, right?
Ma'am, this chapter will be there for this term only, right?
This, sorry, what are you saying, Harsha?
Ma'am, this chapter will be there for this term only, right?
This term means your coming examination.
Yes, ma'am. Like
See,
not for pre-midterm, ma'am. For the midterm, it will be there, right?
yes, it will be in the midterm, not in your June exam, right? I think only 2 chapters are coming, as you told me.
Three, ma'am. The first three.
First 3, polynomials and linear equations.
And real
Okay,
numbers.
real numbers. So real numbers, have you done with me, Shri Harsha? Were you there in the
Yeah.
classes for real numbers? Yes.
Yes, ma'am.
Okay. So first 3 chapters we have completed, and I will be sending you assignments for all the 3 chapters. And then like in some classes we will be discussing those questions. Right.
Okay, ma'am.
Because anyhow we have to complete all the chapters, and also please share the syllabus with me, both of you, for your next term, so that we can plan the chapters accordingly. We will finish the chapters which are coming in your next term exams, so please share with me your timetable. Okay.
Okay, ma'am.
Okay, the syllabus, I mean the prescribed syllabus for the next exams. So wait. Okay. And Hamna, please try to keep your mic unmute. I hardly hear your voice nowadays. All right, now what is arithmetic progression? So before coming to arithmetic progression, I want to uh, make you observe a few things. First of all, let me give you examples of some series, right? Let's say I'm taking a sequence of prime numbers. Uh, what is the first prime number? 2, 3, 5, then 7, 11, 13, and so on. It will go on, right? Okay. And I take a list of numbers here, for example, 1, 2, 3, 4, 5, or something like that. Or another 7, sorry, 100, 70, 40, 10, like that, right? Actually, these four are from book only, but I want to make a few things clear. So I'm taking the same examples and we will discuss every series here. Okay, these four I have taken. Now come to here, this prime number, list of prime numbers. Let me use a different pen. Now, what is, if I take this term and this term, right? What is 3 minus 2? So the difference between the term, if I subtract this term, I get 1 here, right? What is 5 minus 3? I get 2. Then 7 minus 5 is how much? 2.
2,
How much is 11 minus 7?
3,
No, 4. Yeah, 13 minus 11?
2.
2. Yes. So you can see the pattern is not same everywhere. Somewhere the difference is 2, somewhere the difference is 1, somewhere the difference between the number is 4. So it's such a series. Now come back here, 1, 2, 3, 4, 5, the left hand side, this one. Now you subtract this number from this. What you will get?
1.
1. Similarly, the difference here is 1. You take any term, you get the difference 1, right? So you can see, like, if we add 1 to every term, we get the next term. So there is a pattern which is being followed here, right? Now come to the second example. Now, the second term is basically 100 minus 30, isn't it? If I do 100 minus 30, I get 70. Then if I do 70 minus 30, I get 40. 40 minus 30 is 10. So again, there's a pattern which is being followed, right?
Yes, ma'am.
Yeah. So I can write it like this, 100 plus. So basically minus 30, I'm adding everywhere. So I get the next term. Similarly, 70 plus minus 30. So I get the next term. So there's a fixed pattern. Again, come here. What is the difference between the terms? If you subtract minus 2, minus 3, what will you get? So minus 2 minus of minus 3. So you will get how much? Plus 1. Yes. Similarly here, you will get a difference of plus 1. Similarly, you will get a difference of plus 1, 0 minus minus 1. So you will get a plus 1. So everywhere the difference is same. Now here also the difference between the term is same, which is 0. So in such types of sequences where there is a general rule which is being followed, so such sequences are called progressions. Understood? So the sequences where we follow some rule, some kind of general rule can be formulated. So such sequences are called progressions. And this is not a progression because there is no general rule which is being followed here, right? So this is not a progression. Okay. So this is just a sequence. I can say these are also sequences, but these sequences are also progressions. Got the point?
Yes, ma'am.
Yeah. So these are also sequences. These are also sequences. But left side of sequences are actually progressions because there is a general pattern, general rule which is followed. But the right side of sequences are just sequence. It's not a progression. Now, progression can be of different types. It can be an arithmetic progression. It can be a geometric progression. It can be a harmonic progression. So all of these like geometric and harmonic, you will study in your higher classes. Right now you have to know what is an arithmetic progression. So progression you understand now, right? Okay. Now what is an arithmetic progression? First of all, like write down the definition, then we will give some examples to explain what is an AP. Which is also called AP in short, arithmetic progression, right? So an AP is a list of number in which each term is obtained by adding a fixed number to the preceding term, except the first term. Okay, now try to understand. Please write it down, then I'll explain. So see, I'm just breaking it now. So AP is a list of number. So it's any list of number. Now what is special about this list? In which each term is obtained by adding a fixed number to the preceding term, right? So we add a fixed number to the preceding term to get the next term, except the first term. So first term will remain first term, then you will add a fixed number to the first term to get the second term, right? So for example, again, this series, if I take, wait, let me take one example. For example, 4, right? 7, 10, 13, and so on. So you can see if I add 1 plus 3, so I get my next term 4, right? Similarly, if I do 4 plus 3, I get my next term 7, right? Similarly, if I do 7 plus 3, I get my next term 10. So you can see there's a fixed number 3 which is being added to every term. So such type of list of number or such type of sequence is called an AP. So this is an AP. Got it?
Okay, ma'am.
Yes.
Okay. Now this fixed number is called, also write it down. This fixed number is called the common difference. So this is a special name for it, common difference. So you have to remember this term, common difference. Okay. Now look here. This is 1, 4, 7, 10, 13. This is your AP, right? So either it is formed like 1 plus 3 is equal to 4. 4 plus 3 is equal to 7. So if I do the reverse, like if I do 4 minus 1, I should get that fixed number, isn't it? Or if
Yes,
I
ma'am.
do 7 minus 4, I should get 3. Similarly, if I do 10 minus 7, I should get 3. So if I'm going like this, so I'm just adding that number to every preceding term to get the next term. And if I want to find what is the difference between the term here, like if it is already given that it is an AP, for example, I know this is an AP. So how can I find that common difference? Common difference will be found out by subtracting the like next term, or by subtracting the preceding term from the next term. Okay. So basically, okay, you denote it by D. We denote it by D. Everywhere in the book, this common difference will be denoted by small d. Now, D is actually your AK plus 1 minus of AK. Like AK is your any term, third term, fourth term, fifth term. So if you want to find the difference, you will subtract, for example, you are taking fourth and fifth term. So you will do A5 minus A4. Got it? You will not do A4 minus A5. Always the the term at the higher place minus the term at a lower place. This will give you the common difference, D. Please note it down. And there's one more thing about D. Now D can be positive. D can be negative also. I'll give you examples of each. And 0. Yes, written.
Yes, ma'am.
Okay. Now consider this first, the series which I already given you, 1, 4, 7. So 1, 4, 7, 10, 13. So now I'm saying already they are AP. Okay, you know they are AP. So what is the common difference here? So D, how will you calculate D? You take any term. Let's take A3 minus A2, right? You can take any two terms. So A3 minus A2 will be 7 minus 4, which will be 3. So in this AP, you have a positive common difference, right?
Ma'am,
Hmm.
K is the number of the term.
Yes, K denote the number of the position of the term.
Okay.
Not, yeah, position. You can write here like K denote position of the term. It will be clear. Like we will do questions, so it will be clear in your mind. So A3 means third term, right? A2 means second term. So K is the position of the term. Now, an example of AP where you have a negative D can be this, which I gave you earlier, 70, then 40, then 10, right? So how will you find D? You take any term. Again, let's take A3 minus A2, right? So if you take your A3 is this and A2 is this. So 40 minus of 70, you will get minus of 30. Fine. So but by your own will, you cannot do 70 minus 40. You will always do A3 minus A2, not A2 minus A3. Got the point? So in this case, you are getting a negative common difference. So this is an example of arithmetic progression with a negative common difference. And also an example of zero common difference can be this, which I already gave, 3, 3, 3, 3. So the common difference is everywhere 0, right? D is, let's take the same, A3 minus A2. So you can take any, okay? You can take A4 minus A3 this time. So A4 is this, A3 is this. So 3 minus 3, which is 0. So this is an example of arithmetic progression with a 0 common difference. So this much about the common difference. Now one more thing before coming to the first exercise. So you understand what is an AP now?
Yes, ma'am.
So it's a special, list of numbers where the next term is obtained by adding a fixed number to the preceding term. That's it. So basically the difference between the term is called the common difference. Okay, now how do we write the general term of an AP? For example, again, let's say the same one I'm taking, 1, 4, then what was that? 7, 10, 13, right? Okay. Now I ask you, so how many terms I'm giving you? 5. This is the first, second, third, fourth, 5, fifth term. Up to fifth term, this is your A5, fifth term. Now, can you tell me what is the 25th term of this AP? Right? So, or even you can have large numbers, decimal numbers, or so it's so difficult. I mean, you will not sit and write all the numbers and then you will tell me what is the 25th term of this AP. So there, as we know that there is a general rule which is being followed. So first of all, we will try to derive that general rule. So by directly using that general rule, we can tell whatever term is being asked. So how can we do it? Now look here. The first term, right? for any AP, the first term is what? A. Let A is the first term, right? First term is usually denoted by A. Then how will I write my second term of the AP? I'll add the fixed number, isn't it? Which is the common difference, right, Shriharsha?
Yes, ma'am.
Okay. Then the third term, how will I write my third term? I'll again add the fixed number. So this will be A plus D
2D.
plus D, A plus 2D. Then the fourth term will be written as, again, one more D I'll add. So A plus 2D plus D. So A plus 3D. Now you observe it very carefully. Hamna, like see here. When you have 4 here, you are getting a 3 here, isn't it? Like one
Yes,
less.
ma'am.
You are finding the third term, so you are getting 2 here. Similarly, for the second term, you are having 1 here. So if I want to write the nth term, how will I write?
A plus n minus 1D.
Exactly. N minus 1 into t. So this is how I write the nth term of the AP, which I denote by an, right? In the subscript, I write an n. So for any position, I can use this formula, a plus n minus 1 into d. So this is the general formula for like nth term of the AP. Please note it down. Then I'm coming to the exercise. This is actually called nth term of the AP. Where A is first term and D is the common difference. Yeah, there's one more thing. There's a finite AP and there is an infinite AP. Now, what is this? For example, let's say I give you this AP 147, 148, 149, right? And so on. And I give you one last term 159 and then I put a full stop. So in this particular AP, you know it is ending at 159. So there's a last term. So this is an example of finite AP. All right. Because this last term is also important in the coming exercises, you will make use of the last term also. And if I give you like this 147, 148, 149 and so on, it will go on. Now I am not saying where it is going to stop. I'm not giving you the last term. So this is an example of infinite AP. Infinite AP. This is finite AP. Okay, now let's come to the exercise. So Harsha, any confusion here?
No, ma'am.
Okay, Hamna, any confusion?
No, ma'am.
Okay, so I hope you understand what is an AP. Now with the help of questions, we will like understand more. Okay, let's do some questions now. Should I share the book itself? Yeah, is the book visible?
Yes, ma'am.
Now see, first question. In which of the following situations does the list of numbers involved make an arithmetic progression and why? So you have to give reason why and why not. First, the taxi fare after each kilometer when the fare is 15 rupees 15 for the first kilometer. and rupees 8 for each additional kilometer. So how will you write it? Like for first kilometer or fare for first kilometer. How much rupees? 15. Okay. Then similarly fare for second kilometer. It will be 15 plus 8, right?
Yes, ma'am.
Which is equal to something 23. And then similarly for the third kilometer, it will be 23 plus 8, right? What is equal to 31, right? Then fourth kilometer, it is 31 plus 8, which is 39. So we can see there's a constant number which is being added to every kilometer, right? So this is an AP. Now how will you write? Like you have to write properly. So we observe there is a constant term or constant number or fixed number. There's a constant number which is added to every kilometer, which is added after every kilometer, or which is added to each term, to every term, right? So there it forms an AP. So you don't have to do like find D and all that. This is just like daily life examples. Yeah, written. Please note it down. Yes, written.
Yes, ma'am.
Okay. So let's come to the second one. The amount of air present in a cylinder. Okay. When like you have to form a list of this amount. All right. Okay. When a vacuum pump removes 1/4 of the air remaining in the cylinder at a time. Let me use my whiteboard for it.
Ma'am, I have a thought.
Yes, say.
Ma'am, the first term doesn't matter if it's in the form of D. Like, ma'am, for the previous equation, it was 8. So the first term doesn't have to be 8.
No, D is 8, right? The first term is 15, right? First term can be anything. Now you will add a fixed number to this term to obtain the next term. Like what is the general, okay, you can note down somewhere, what is the general form of an AP? So I have gave you examples, but I have not written the general form. So general form is like first term is A, right? Now you add a fixed number to this term, then you get the next term. So the next term will be A plus D. Then you add one more D, so you get the next term A plus 2D, then A plus 3D, and so on.
Okay.
Yeah, so the first term can be anything. You can start with any number now, but you will add a fixed number to this number to obtain the next, and the same number you will add to obtain the next, so on. Got it?
Yes, ma'am.
Okay. Now the second example, what does it say? Like let the initial volume is V, right? We do not know the initial volume, so let me call it V. Okay, so initially the cylinder volume is V. Now it is being pumped, and after each what you can call after each stroke, or after each let us call it stroke. So after each stroke, 1/4 of the volume is diminishing. So how much volume will remain after first stroke? So after first stroke, you're pumping the pump, right? Or you're pressing something, let's say. So after one stroke, so initial volume minus 1/4 of this initial volume. So how much the volume remains? Hamna, how much it will remain? How much is v minus 1 by 4v? Take LCM and solve. Yes, Harsha, you tell me.
3 by 4v.
Yes, 3 by 4v. Hamna, why don't you speak up? Okay. Now after second stroke, what will happen? Now second stroke means, what is the initial volume now? This is the initial volume minus 1/4 of this initial volume, isn't it? Got the point?
Yes, ma'am.
Yeah, so please solve it and tell me what will you get. Then again, third stroke, what will happen? Yeah, find out here first of all. So you can see there's a 3v by 4 common, right? Take it common. So it is 1 minus 1 by 4. Again, you will get 3 by 4. So 3 by 4 into 3v by 4, correct?
Yes,
Okay.
ma'am.
Now third stroke. So this is the initial volume and minus 1/4 of this initial volume, which is 3 by 4 into 3v by 4. Got it? So you solve it similarly. Take this 3 by 4 into 3v by 4 common. So 1 minus 1 by 4 again, which is again 3 by 4. So 1 3 by 4 is already there. So you get 3 by 4 whole square into 3v by 4. Right? And in the fourth stroke, I think you will get the same thing. You will get 3 by 4 whole cube into 3v by 4. You can try it, solve it. Now, is this an AP? Yes, Hamna, is this an AP? I mean, look at these terms. The first initial volume is V, right? This is your A. So this is your A plus D basically, right? A plus, like next term, not A plus D. This is the next term. Then this is the next term of this series. This is again the next term of this series. And this is again the next term of this series. So tell me, like, is this list an AP? Is this sequence an AP? Yes, Harsha.
No, ma'am.
Why?
Ma'am, because equal numbers are not added.
Exactly. Equal numbers are not added here, right? There
Yes,
is a
ma'am.
constant number which is being multiplied, not added. Can you observe it?
Yes, ma'am.
Yes. So you write in statement, there is a constant number which is being multiplied. Sorry, multiplied with every term, with each term, with each successive term, right? Please, successive terms. So this is not an AP. So this sequence is not an AP.
Ma'am, in the second stroke,
Hmm.
it is 3v by 4 in the second step.
Yes, 3v by 4. V minus 1 by 4v, right?
Ma'am, in the second stroke.
Mm. Yes, 3v by 4. See, now this is the initial volume, right?
Yes,
So it is
ma'am.
this initial volume minus 1/4 of this initial volume. So I've just solved it. Yeah, this is 4.
Ma'am, how will the v go inside the bracket?
It is in multiplication, Harsha. Whether you write it outside, inside, doesn't matter. All the numbers in the numerator are in multiplication, right?
Okay.
So you can bring it out also. I've actually written this numerical value here, 3 by 4, and this 3 by 4 here. So it's simple multiplication. You can flip it, doesn't matter. Yes, written. Hamna, where are you?
Yes, ma'am.
Written or not?
Yes, ma'am.
Okay. All right, Harsha, I'm stop. Like I'm changing
Okay.
the page. Now come to the third one. The cost of digging a well. Okay, so you have to form the list of this number, the cost of digging a well. Okay, now after every meter of digging, when it cost rupees 150 for the first meter. So for first meter, rupees 15, right? And rises by rupees 50 for each subsequent meter. So if you dig 2 meter, how much will be the cost? It will be 15 and plus 50 rupees, right?
Yes.
Similarly, if you go for the third meter, so it will be again, how much is this equal to? 50 plus 15, 65. So it will be again 65 plus 50, which is 75 rupees. And similarly, if you go for the fourth meter, so it will be 75 plus 50 rupees. No, 50. Sorry, I added 15. Have I done it correct or not? No. Sorry, I just added 15. 5 and 115. Okay, sorry. So 115 plus 50. So what will I get here? 5, 6, 165, like that. Right? Okay. So again, I can see that in each term, a fixed number is being added up, right? So this is an AP. We can observe. Can you write the line? We can observe that a fixed number is added to each subsequent term. So this is an AP. Now, okay, I'm just giving you a brief hint of the fourth one. Yeah, written.
And 1 minute. Done, ma'am.
Okay. Now next, fourth one. So you have to make a list of this, the amount of money in the account everywhere, right? This list you have to prepare. Now 10,000 is deposited at the compound interest of 8% per annum. So the principal amount is 10,000 and compound interest is 8%. So how will you write it? Just a minute. So how will you write it? Like compound interest, what is the formula for compound interest? Amount. Okay, you have forgotten. So amount after first year. How much will be the amount after first year? So this is how we write. Like we write the principal amount here, okay, into 1 plus what is the rate of compound interest, which is 8, right? 8 upon 100. So this is the formula. And then after second year, so it is actually 10,000 into 1 plus 8 upon 100 to the power 2. And similarly, third year, it will be 10,000 into 1 plus 8 upon 100 to the power 3 and so on. So is this an AP?
No, ma'am.
No. In all the examples, you can write the nth term also, like if you wish. So after nth year, what will happen? So it will be 10,000 into 1 plus 8 upon 100 to the power n. So we can again see that a constant number is not being added here, but is being multiplied here. 1 plus 8 upon 100 is being multiplied in every term, not added. So this is not an AP. Can you write it?
Yes, ma'am.
Okay. Okay, done.
Yes, ma'am.
All right.
Ma'am, equal number is not being multiplied there, right? In that question.
The whole bracket actually 1 plus 8 upon 100, that complete bracket is multiplied.
Ma'am, but
Power.
it was squared and also. So we can consider it as unequal, right?
Wait. Where was that? Okay, on my whiteboard. Yes, Harsha. Now see here. What were you saying?
Ma'am, the 1 plus 8 by 100, it's common, but it's getting squared and also raised to the power 3 and right? So it's
Huh.
not
So
equal.
see, the difference is not equal, right? So
Yes,
that is
ma'am.
why it's not an AP, because you do not have a common difference here. A constant term is not being added. It's our observation that it is being multiplied. But for an AP, it should be added up to each term. So it's not being added up, it's actually being multiplied, like this whole bracket, it's being multiplied.
Okay, ma'am.
Yeah. Okay, let's do one more question now. So this is the question, like write first four terms of the AP when the first term A and the common difference D are already given, right? So if I consider the first part, so in my first part, so A is 10 and D is again 10. And you have to write only first four terms, right? So there are two methods of doing it. First four terms will be, what is the general, like you can use, what is the general form of AP? Sorry, general form of AP. It is A, then next term is A plus D, next is A plus 2D, then A plus 3D. These are the first four terms, right?
Yes, ma'am.
So either you can write it like this. So A is 10 or A1 you can call it, or A2 is A plus D. So 10 plus 10, which is 20. Similarly, your third term is A plus 2D, which is again 10 plus 2 into 10 is 20, which is 30. And you can write your A4, which is A plus 3D, which is 10 plus 30, which is 40. So this method is also correct. I mean, your answer has to be correct, right? Or you can use like you can do it like this also. We know the nth term. Nth term is how much? A plus n minus 1 into d, right?
Yes, ma'am.
Okay, so you put the value of a and d here. So a is 10 plus n minus 1 into 10. So this is 10 plus, so 10n and minus 10. So 10 will get cancelled out. So it will be 10n. So whatever n you have here, the same n is coming here. So your a1 will become 10 into 1. Your a2 will become 10 into 2. Your a3 will become 10 into 3. This is n is not subscript. This is multiplication. Okay. And a4 is 10 into 4. So this is also another method of doing it. Yeah, please note down. Or you write here, right? Nth term. An is equal to this thing. Yes, Hamna, any problem? Yes, Harsha noted.
Yes, ma'am.
So similarly, you can do other parts also. Let's try the fifth one. So your A and D are given, right? So if I write the nth term for this AP, what is my nth term? An, which is again A plus n minus 1 into D. So how much is A? A is minus 1.25 plus n minus 1 into D is again minus 0.25, right? Okay. So you now multiply. So minus 1.25 and so plus minus will be minus 0.25 into n, and then minus minus plus, and you have 0.25, right? Okay. Now how much is this? 1.25 minus 0.25. So you will be left with 1,
1.
right? Yeah. And minus 1. So minus 1 and minus 0.25 n. So this is actually your general term you have obtained. So now you put the value of n is equal to 1, 2, 3, 4, and you will get the subsequent a1, a2, a3, and a4. So can you do it?
Yes, ma'am.
Okay. So in all the parts, like this is, I think, more convenient way of doing. You obtain the general term because see in this formula, basically there are three unknowns, right? One is A, one is N, and one is D. Two are already given to you. You are only left with N. So you just substitute the value of N and you can obtain the term.
Okay, ma'am.
So similarly, you attempt all the parts. Okay, third question also, let's take a quick look. It's very easy. Now, for the following AP, write the first term and the common difference. So like it is already given that it is an AP. So write the first term. So first term, you can see, you can write. Let's try the second one. What is the first term? That is A
-5.
minus 5. Okay. And what is the common difference? D. Now, okay, now please listen one point here. When it is already given that it is an AP, okay, you don't have to check, right? There might
Yes,
be
ma'am.
a sequence which is given. It's not given that it is an AP. So you will calculate every difference. So you will check whether the difference between all the terms is same or not. So if the difference is coming out to be same between all the terms, then it is an AP. But in this question, it is already given that it is an AP. So we do not need to find each and every difference. We can take any two terms and we can find the difference. All right.
Yes, ma'am.
Okay. So if I take D is equal to this is your A1, A2, A3. Any two terms you can take. Let me take 3 minus 1, right? So this is 3 plus 1, which is 4. So your D is 4. That's it. Or you can write it properly, like D is equal to second term minus first term, like that. If you want to stick only to the second and the first term, you can do that also. So there also you will get this. So minus 1 minus of minus 5, which is again 5 minus 1, 4. Okay. Yes, Hamna?
Yes, ma'am.
Because the formula is this, right? K plus 1 minus of dk. So you can take any k. So if you are taking k second, so third term minus second term. If you are taking k1, so second term minus first term, whatever you can take, you wish you can take. So I am taking second term minus first term. You can take third and fourth and fifth, whatever.
Ma'am, in the previous question,
Hmm.
n will be the
Nth
n will be
term.
2, right?
N
2,
will be
3, and
what?
4, right?
N will be, yeah, N is actually number of term, right? A1 means your first term. A2 means your second term. A3 means your third term. Understood?
Yes, ma'am. So A1 we don't need to find it.
No, A1 is actually A, right? We denote it by A. The first term is usually denoted by A only.
Okay, ma'am.
Yeah. So A1 is actually A.
So A1 will be minus 1.25.
Uh, A1. Yeah, you have to put N is equal to 1. So it will be minus 1 minus 0.25. Yeah, it will be added up with a minus sign. So 1.25. Yes.
Okay, ma'am. Like it was given in the question only. So
Mhm. Yeah, it was also given. What were you supposed to find? First four terms, right?
yes, ma'am.
Yeah, these are the first four terms. First term is already given, so second, third, and fourth you will find out. First four terms or next four terms? What was the question? Read it properly.
First 4 terms.
So first four terms, so you will include A also. Yes, you can check the answers also, I think. First term is included. So it is 10 minus 1.25 is the first term, and then next three also you will write. So I think I should end here today. Whatever questions I have left, please complete it.
Okay, ma'am.
I think you can give it a try. Fourth question. It's saying which of the following are APs. So basically, when you do not know if it is an AP or not, so you will find D everywhere. You will use second term minus first term, third term minus second term. So you will see whether the difference is same or not. Got the point, Hamna?
Yes, ma'am.
Wait, just one example I'm giving you. So you have to try this question also. So look here, like first one. So you do not know whether it is an AP or not. So you will do uh, like this is your A1, right? So you will check A2 minus A1, then you will check your A3 minus A2, then your A4 minus A3. Only 4 terms are given. So they should come out to be same. If they are coming out to be same, then this is an AP. And also write what is the common difference. So whatever you will get here, which will be your D. So you have to tell how much is your D and write 3 more terms. So how will you write 3 more terms? So let's do the first one. So how much is A2 minus A1, which is 4 minus 2, which is 2. So your D is equal to 2, right? Similarly, you can check A3 minus A2, which is 8 minus 4. Oh, this is 4. So it's not an AP, right? So this is not D. First of all, check all the terms. So A4 minus A3, which is 16 minus 8, which is 8. So here the difference is 2, here the difference is 4, difference is 8. So not an AP, right?
Yes, ma'am.
Okay. Similarly, you will see if the difference is coming out to be the same, so that will be your common difference. So you will mention what is the common difference. And you have to write 3 more terms. So let's say A4 till A4, you know. So you will do A4 plus D. Then again,